Now, a lot of people will ask, is it possible to do this, Ray? Can we divide 9 into 7? A lot of people will turn around and say, you certainly cannot. Actually, you can. And how simple is this to do? You will be amazed at how easy it is. It's simple. Right, we know for a fact that 9 does not go into 7, okay, because 9 is bigger than 7. 9 is a larger number than 7. So all you've got to do is put point there, okay, and add what we call trailing zeros. And they can trail on for as long as you want them to trail, okay? It's very unlikely that your teacher will ask you to give a division as long as that, okay? Very unlikely. So we are only going to go up to this point here, up to 3 zeros, okay? And it's as simple as this. We forget all about the fact that that point is there. Forget all about it. It's as simple as this. We're asking ourselves, how many times does 9 doesn't go into 7, does it go into 70? We're only going to go up to that point there. We're asking ourselves, how many times does 9 go into 70? It does, in fact, go in 7 times. 7 times 9 is 63, okay? And it's the same procedure. 7 times 9 is 63. We're taking that away. It leaves us with 7. Again, bringing the next number down. 0. It's going to be the same answer, isn't it? 9 into 7. It goes in 7 times. 7 times 9 is 63. That leaves 7. Bring the final 0 down. Running out of paper there. 9 into 70. Again, surprise, surprise. It goes in 7 times. And that is just going to go on and on and on, isn't it? You know, it's just going to be the same. That's just going to be recurring, okay? That is going to go on and on and on and on and on. So you could show that there. How many times does 9 go into 7? It goes in 0.77 times. Okay? That's where your trailing zeros come into it. 0.77 times. That's how many times 9 goes into 7. Right. We're now going to move on to another long division for you. This time a little bit trickier. No point making them too easy. Okay, 14 into 21,758. And we're going to show this one as a decimal, if need be, if we have a remainder. I'll show you how to do that. 14 doesn't go into 2, doesn't go into 21. Of course it does, once. Remember what I taught you before? 1 times 14 is 14. We're taking it away, aren't we? That's going to leave us with 7. And don't forget, we're not putting 14 into 7. We've got to bring that number down again. Right? 14 into 77. Right, if you're getting a bit mixed up at this point here, you can always use a method that we call chunking. Just a simple case of addition. You can do it this way, or you can do it this way: 4, 8, 12, 16, 20, 24, 28. 2, 3, 4, 5, 6, 7, 8, 9, 98. Right. Basically, this is how I do it. 14, 28, 38, 42, 46, 56, 60, 70, 71, 2, 3, 4, 5. We know that 14 goes into 77 5 times. Okay. Then we're once again asking ourselves, what is 5 times 14? It's 70. Another way of doing it is 5 times 4 is 20. 5 times 10 is 50. 50 plus 20 is 70. Okay. Sorry, that's at an angle there. And again, we're taking it away. We're left with 7. Next step, bringing the next number down, which was 5. Okay. 14 into 75. Okay. And we may have done that wrong, in fact. No, we have done it right, sir. Okay, 14 into 75. Now we're asking before how many times it went into 70. Right. Right, so well, it's going to be 5. It's going to be 5 times again, isn't it? Let's put the 5 up there. Okay, so it's going to be 5 times again. And so once again, 5 times 14 is 70. The little minus sign. Leaves us with 5. The final number we're bringing down is the 8. I really must apologise for that terrible writing, but I'm holding this in a very awkward fashion. Ha ha ha. Much easier when I got my blackboard in the classroom. Right, what's 14? What's 14 into 58? Let's have a look at our chunking again here. 1, 2, 3, 4, 5, 4. 4 times 14 is 40, is 56, isn't it? 4 times 14 is 56, right? Chunking is quite handy, to chunk the numbers together, because who knows the 14 times table? Not many people do. I certainly don't. Right. If you do, good on you. That's what I say. Right, we know that goes in 4 times. And once again, what is 4 times 14? 4 times 14 is 56. We take 56 away, it leaves us with 2. So we've got quite a small remainder this time here. And the small remainder is 2, which we can show as 2/14ths, or we can show as a decimal. Now, how do we show that as a decimal? Once again, put the point at the end of the 8 there. Let's just add 2 this time, but as to say, it doesn't matter how many you add. Let's just add 2, and now it's just a simple case. It's just a simple case of bringing that 0 down to join the 2. Okay. Nice easy one this time. 14 into 20. We know that goes in. Don't forget your point. It goes 1 time. Right. Again, we're just following the same procedure here. 1 times 14 is 14. Oh, it's sore in my hands. And again, we're taking it away. It's leaving us with 6. And bringing down the final 0. As I say, we could go on further. Right. Again, now we're asking how many times does 14 go into 60? It goes in 5 times, isn't it? No, it certainly doesn't. I think that only goes in 4 times. 4, yeah, 5 times. What am I talking about? To show you the sum equations so far. It goes in 4 times. 4 times 14 is 56. As I say, we could carry this on and carry it on. Carrying it on, it'd just be a simple case of it'd be a simple case of doing this. 4 times 14 is 56. Take that away, leaves you with 4. And then you're bringing another 0 down. If you had one, then it'd be how many times does 14 go into 40? And that goes in, of course, twice, okay, etc., etc., etc. So there we have it. We know that 14 times 1,554.14 is 21,758. 14 times 1,554.14 is 21,758. There it is, shown as a decimal. I'm just going to leave that up for you there. You can pause it and look at it and go over what I've just said if you like. Right, now we want to double check that, don't we? So again, how do we double check it? Multiplication gets you to the same answer as division. Now this is a good way to show our multiplication here. So we're asking ourselves, what is 14 times? What is 14 times 1,554? Okay, we're not going to bother about the decimal just now. And this is how this is shown. Ah, the joys of having a second pen. Right. It is tricky to do this actually, to be honest with you. Right. Why have I added so many lines under there? Right. Line number 1 is for your units. Line number 2 is for your tens. Line number 3 is your total. How do we get to our total? We add the units to the tens. This could be going on. This could be like, this could be into thousands. If that's the case, you just keep on adding more lines. So you have units, tens, hundreds total, or units, tens, hundreds, thousands total, and so on and so forth. $21,756. And how does that equate? That proves that we have done the sum correctly, because it gives us a remainder of 2, and that is what we got here, didn't we? We got a remainder of 2. Okay, there was a remainder of 2, but we turned it into a decimal, remember? Okay, so that would have equated to 1,554 and 2/14. Okay, but we changed it into a decimal. which is 1554.14. Okay, so that multiplication proves that we have done the division correctly, despite me making a mistake earlier. So remember, chunking, easy to make mistakes. Quite often it's something simple like you've forgotten to carry a 1 or you've added one number over too many. But you can even check that in your calculator back home and see if that is the correct figure. So we have shown you long division, chunking, and we have turned decimals. Well, we've turned fraction into a decimal, haven't we? Okay. It's quite easy actually to turn a fraction into a decimal. How's that done? Turning a fraction into a decimal. Let's make it a proper fraction, okay, not an improper one. An improper fraction would be something like this. Okay, that's an improper fraction. A proper fraction is that. Okay. Now, how do we turn that? How do we make that into a decimal? How do we do it? Is it possible? Are we just going to give up? Are we going to jump out the window? Yeah, I think we will. No. Denominator, numerator. Numerator, denominator. Denominator goes into the numerator. Denominator goes into the numerator. Again, we're just adding trailing zeros. You can add them on forever if you like, and it just becomes a multiplication. 16 into 80. How many times does that go? 4, 40, 40. What's 4? 5. What's 4 times? It's 40. What? 40. It's exactly 5, isn't it? 5 times 10 is 50. 5 times 6 is 30. Exactly 5. 5 times 16 is 80. Take that away, and it leaves us with nothing at all. Okay. Eight sixteenths is 0.5 as a decimal. Well, that was quite an easy one right now because we actually knew that was exactly half. It probably wasn't the best example to show. Try 3 nines. Remember, numerator, denominator. How do you work it out? We're basically turning it upside down, and we're putting the denominator into the numerator. And this is how it's done. We're just creating zeros. And it's just a normal division. 9 into 3 doesn't go, 9 into 30 does go, it goes in 3 times. Okay. It's like a Z. Right. Nine. That is just going to be the same figure over and over and over and over and over and over and over again. It's going to be 0.3333 recurring. Okay. You see how it's working out. Okay, it's just, you know, we're just going to get to that all the time. So from here we can say that 3/9 as a decimal is 0.333333333 until all eternity, until infinity and beyond. Or we can just say 3/9 are 0.3 and put a little r, 0.3 recurring. Another one quickly. Very quickly. Very quickly. Again, remember, we're turning the sum on its head, creating zeros, okay? It's all a question about trial and error. Quite easy to make a mistake. In any case, it's best just to stick to 3 zeros, because then it just gets silly after this, to be honest with you. Because it's very seldom you'll be asked for a decimal which you know, is like 6 digits long. That's just being silly now. Okay, so again we'll do the same thing. Okay. Two times 21 is 32. Take that away, and it leaves you with 18. Right. So I made a mistake earlier on. That's right. You've got to wait. I almost fell into one trap there. I warned you about that before myself. Okay, you don't put anything up there until you've brought a number down. Okay, 21 into 180 goes in. So close to going to nine times. It was going to go into 8 times, isn't it? All right. 8 times 20 is 168, isn't it? So then it's 180 minus 168, and that is going to leave you with 12. And then it's just a case of going on and on and on and on and on. Right. So we know that 9 over 21, okay? 9 over 21 is equivalent to 0.428. 9 into 21 is equivalent to 0.428, and you could have shown the decimal figure as a longer figure by just adding more what we call trailing zeros. 9 over 21 is 0.428. Again, it's just a case of putting the sum on its head, okay? And the denominator is going into the numerator, okay? And that is how we get that. That is how we get that answer. Thank you very much indeed for staying with me in this show. And that is basically, it is long division, short division, it is converting fractions into decimals, it's also chunking, and oh yes, and it's also showing you improper fractions as well. That time we put 7 into 9. You know, it shows that you can divide a larger number into a smaller number to create a decimal figure. Right, there will be more, I'm sure, but for now, it's good night for me, and I hope this was some help to you all. See you later, folks, and keep on practicing.